major projects speak for the ALMA, SMA, YTLA, GLT, DLBI. I want to thank those people who sent me the files. If any question come up from the audience, you may need to answer the question for me. So the first one I'm going to talk about is the ALMA project. This is the ALMA. So I want to remind you, we're now in the operation phase, 10 years period, from 2015 to 2024. We have two channels, ALMA, consisting of Japan, Taiwan, and South Korea. We have a grant from AS, $1.5+ million, including the Band 1 receivers, Taiwan announcing note, Band 11, terahertz developments and science activities, and also we have another channel, ALMA NA channel, US, Canada, Taiwan, supported by most grants, up to $2.2 million per year, and consists of cash contribution and ASIAA Panel Development Center, ECDC, the Software Development Center, and then Greenland Telescope, and science activities. Here's the management team. So Yuhua, our director student PI, and co-PI Patrick, he's not here today, me, and project manager Patrick, and project scientist Wei Hao, and Tang Tang, and project engineer Ning Tang. And we have 5 sub-projects from Band 1, terahertz, ACDC, ARC, and Greenland Telescope. Greenland Telescope kind of into separate project management. So in total, we have 70 staff members, including faculty, support scientists, postdoc engineers, and also we have UCAT on the university side, the University Consortium of ALMA Taiwan. This is just a reminder of previous. Oh, sorry. Come to the first page. Okay. Now we'll continue with the progress report on the Band 1 project. The Band 1 like our director says, it's moving on. So now in production phase. Here's the 20 receivers front end. Front end ladies in Taichung, Taiwan, 20 of them. And this ALMA director, Sean, visiting the ARL in Taichung early this year in March. And the Band 1 to be completed in 2022. So this contribution is mostly EA ALMA contribution, but also international, including the NOJ, NRO, Taiwan, University of Chile, HIA. And Band 1 the remaining receivers band, access to 35 to 50 gigahertz. The science drivers are evolution of grands and planetary disk, detection of molecular line, emission from high-res to galaxies, and many more, Z-effect, Z-band, chemical tracer, etc. And sampling out, integration and testing being done in Taiwan at EA Front-End Integration Center facility. Continuing a successful EA team, ideal transfer of knowledge and expertise. So right now we have 20 receivers units sampled, tested. The fourth strategy is the next major milestone is manufacturing readiness review, the MRR. It's very important that the pass this step to move forward into the mass production. The late supposed to be the end of this year, and the first receiver shipment to be on the end of 2019 to June. Recent progress towards MRR is all specification change requests submitted and documentation ongoing, and project management plan updated and being released. So everything looks like it's on track now. The next one is the ACDC activities. So I'm the PI of this one. It's the first visualization project for Carton. And this is our front homepage, and it's developed by 4 teams: ASIAA, IDIA in South Africa, NRO, and the University of Alberta. Here's the is a tall cube analysis and rendering tool for astronomy. It's tool for the ALMA, VLA, SK pathfinders. Because the image become bigger and bigger now, so the mission is to provide usability and scalability for the future by utilizing modern web technologies and computing parallelization. So this is kind of the first release, official release last year, December. This is the image viewers. You can see the profilers, spatial profilers, spectrums, and the statistics and animations. And this is our face-to-face meeting in early this year, in January, in South Africa, Cape Town. People from different partners attended. This is our more recent release, just early this month. We added the regions of interest, so you can select the regions and then can look at the statistics. And also can select create regions and also the spectrums, and also the spatial profiles too. And this is our next releases roadmap. So we are going to have added different kinds of regions of interest, polygon, point, importer, exporter regions as well. The tile rendering makes it faster, and profile delivery, optimization, performance, blah, blah, blah. And also the 1.3, the world coordinate system, so they can overlay different files, different coordinates system, and also plot the contours on top of each other. And hopefully, at the end of this year, we can have the scripting interface and use Python to do the plotting. Multi-panel image viewer, multi-analysis tools, scripting interface. This kind of our release roadmap. The next one is the ARC, ALMA Regional Center and Science Activities. Here's a Taiwan ARC node holding a meeting. It consists of us 10 people right now and supporting core functions of P2G, QA2, current science help desk, technical assessment, LD, currently on duty, and current 10 members. And these are the one workshop together with the EA regions. And there's a proposal writing camp in early this year. So you can move people to write proposal as early as possible. And hopefully this year will have a better success rate. And this is a workshop early this year for the cycle 7. So we have one-day workshop. Updating people with the capabilities, science portal, learning tool, and learning how to write ALMA proposals, and what kind of tools you can use to make your proposal better. And this is the proposal statistics from cycle 0 to cycle 6. So this success rate, you can see the 1.18 down to about a quarter something. The overall success rate is about, from Taiwan side, is about 4, and the overall is about 4 as well. And this cycle, about 1,800 proposals submitted, and Taiwan submitted 93 proposals. Last year it dropped to 72, but this year it's increased to 93, back up again. Hopefully the success rate will be high this year. So in principle, we do pretty well in getting time and publishing papers. So these are publication statistics. Can you hear me? Okay, so total is like right now 1,420 papers. We have here Taiwan's 3%, but this here doesn't include the paper by our Taiwan's people located in a different area. So we include that also in the 4.3%. So this that we counted, the first order that we counted for Taiwan's institutions. So up to now we have 62 actually. So it's overall like 4.3% applications led by Taiwanese affiliated researchers. Okay, Okay, so that's all for the Taiwan, for the ALMA project. Next one, go to the SMA status to conduct to 2026. So prepared by Naomi, Minjie, and Bintang. So I have three components. So I have receiver lab, SM operation, and SIS mixers for the WSMA receiver, and scientific program led by Naomi. So the current status, this is the current status of the array receivers. So we have equipped 4 wide bands. The IF frequency is 4 to 16 gigahertz. But right now we're using the 12 gigahertz on wide band mixers were installed in the current viewer. You can do simultaneous dual frequency operation. Not only that, we can do full polarization observations. So this is kind of the coverage of the 4 frequencies receivers: 240, 230, 400, 345, and the frequency coverage by these 4 receivers. And this Q1 to Q4 covering the 8 gigahertz is the L frequency, the same as 2018, so 8 gigahertz per sideband bandwidth. But we can combine dual receivers. We can make it 16 on each receivers, and then the total will be. We can shift the L frequency. They can have 4 sidebands next to each other, and the total will be 32 gigahertz. Continuous frequency coverage is very nice. So from SMA to WSMA, so current to present now, and the later one we have called low band and high band. Then the I frequency can go to 20 gigahertz, much wider now. 16 gigahertz upper sideband, 16 gigahertz lower sideband, and times 2 polarization. So that would add up to 64 gigahertz bandwidth, and they can do a 2 bands receivers and make it to 128 gigahertz. Instantaneous coverage is very nice. And this is a WSMA cloud-stack receiver. Attached pictures of 2. This is receiver coverage, and this is cloud-stack, and this is cloud-stack in the cabin. And here's the progress in writing. So this is current SMA receiver upgrade. So as show you, this will be done before June, and this receiver had wide bandwidth up to 20 gigahertz. We deliver a block down converter delay to mid of May to test the swarm Q5 and Q6 have to wait until the block down converter are ready. So far we have Q1, Q4 working. WSMA receivers cloud stack is more important thing. The CDR, the critical design review was held at early March, and the expected on-site checks September this year. The lab test in SAO is around October and November, and our staff will join the test. Installation test on TestCode is scheduled before the end of December. And other key components are the low band mixers, high band mixers. Over the first version are comply with the specifications, which is good. The second version will be delivered before July to further improve the performance and stability. High band receivers have been done, the design is done. The final design will be done after the low band mixers finished. And the other components, cryogenic IR filter, still are done. The core check will be done in ASIAA, and directional coupler for high band receivers. The boards have been fabricated and tested. Frequency shift to high and about 15%, preparing the application of the second version. Duplexer bias T to cover even the lower frequency, lower IF from 0 to 4 to make it a full 20 gigahertz IF band. For IMT orthogonal mode transducer, working on traditional waveguide type receiver cartridge, pending until the OMT is finalized. So the working groups formed to cover the test for installing the new receivers, including optics, electronics, and other necessary works. plan the configuration of new user telescope cabinet. I think the schedule, as told by you, was kind of delayed, but it's highly dependent on the color stack. And if the color stack issues goes well, we have 8 new WSMA receivers at the end of 2021. The spare 2 could be ready by the mid-2022. Here's a site operation. There's people know more about this. So this is the tracks requested in green bars, and the blue lines and dots, the IAA proposals. So about 20 proposals. Used to, the highest one is 32 proposals and going down to 20 something proposals. But the request time actually is not that different from year to year. It's about 45 to 50 tracks requested. The oversubscription rate is about 2 now by the proposals, even lower than 2. But by the request time is about slightly above 2. From the highest one is going to go up to 4, but right now so far to 2. I think users have shifted to ALMA, some of them. And the number of proposals from EA since 2078. So the number of proposals are kind of decreasing. I think probably because of the same number of people proposing. They have state data already, so in the beginning, they don't have data, and then we propose it, and later that data. And these are science operation proposals from 10 years, statistics, times proposal in the joint ranking. So this is top 25%, 25 to 50%, 50 to 70%, bottom 25%. So you can see kind of increasing the bottom 25% and roughly slowly increasing. And the top, the average, I don't see much difference, but like here's kind of, this is overall the total. So a bit less than a quarter. This is a bit more than a quarter. And here and that one kind of roughly a quarter each. So the question here is the bottom, how to bring this up to the top 25%. So how to utilize our SMA time efficiently. The proposed mode by, we have the SMA group meeting and also proposing faculty and said, I need to allocate 50% of the SMA time, our SMA time to key projects, science projects, to multiple semesters, and to have that, the rest to the regular projects so they can increase the borderline to here, something like that, to get 60% cutoff. Right now it's over here, such a range about 2, make it higher. Hopefully can increase the proposal qualities. And the science operation application decreasing trend in the last few years. You can see the blue bars are first order papers, kind of decreasing. These are 14 years, decreasing from 15 to 6 something to 5 to 600 over the past few years. I think SMA pointed out the issue because SMA users shifted to ALMA. It's kind of natural, expected. Student paper in the last 5 years has steady about 2 papers per year, 1 or 2 papers per year. So an SMA activities about how to raise the quality, how to get more people to work, especially students, science workshops, venues, Asia Taipei, at the end of this year's, November 4 to 5, 2 days, so combined with the JCMD from November 6 to 9 in Asia. And also we're going to have an inter-family school next year in Hilo, 2020, Jan 12 to 17 in Hilo, so that people can get their hand-on telescope again. So this is kind of the status for the SMA. The next one is YTLA, Ian's array, prepared by Jeff Power. So this kind of collaboration between the 3 different groups are YTLL, YTL array, and time, and then this kind of studies like VLAs, ASIAA, SMA, ASIAA. So probably different materials, CO, molecules, gas, ionized gas, high electricity gas. 1 to 6 in between this and that. Yeah. And these are scientific goals and impact, property cosmic dawn, evolution of gas in galaxies from 1 gigayear. So this is a box of the galaxies and gas and iron, gas, ionized gas, and neutral gas, talking about different instruments. LOFA, Amoeba, and this is ALMA, ACA, and this is time, ionized gas. Okay, and right now it's kind of in the commissioner state, and science, first science too. The achievements, the transition to science operation underway, so 50 hours per month. Data pipeline for intensive mapping kind of already established. Still science projects are underway. We have shown results in this talk, and extensive commission of systems, and transition from 15-year-old control computer to new system, and 8th antenna installation, spare component assembly underway, successful collaboration meeting, and ongoing work, array sensitivity needs improvement, bring up that to better sensitivity, and shelters kind of all now needs repair and replacement, operators, hiring full-time observing and need more operators, increasing efficiency and procedures to achieve routine operation observing. Well, going to detail. So intensive mapping pipeline implemented. So here's the results. Here's the model, the predicted model. This is model B, this is model A, and here's the status of YTL over here. So 4 hours cost on data from April last year, and calibration pipeline linked to intensive mapping pipeline, true for diagnostics, calibration and science kind of done. This is the data. Yeah, this is 1 sigma noise level. Yeah. Hopefully, can after a few hundred hours, can bring this down to here and see some detection. So these are cosmic integration baselines. So far, we had 7 antennas, right? So like 6. So 6 antennas of 6 type 5 baselines. And this sidebands, 2 sidebands, different color for different sidebands. We achieve at 0.19 density per baseline in 4 hours integration time. And this is a correlator efficiency commissioning test. This is a new slope equalizer provides flat bandpass and show correlator efficiency to be close to zero value. It's not so bad, 0.187 and flat. And band is 1 gigahertz. Well, upper sideband and lower sideband. It's different color. But anyway, I think this is green, orange. Yeah. And this is observing time. So this is the kind of statistic of the past year. It's 1 year period. So 1 year period, different others. This green is the intensive mapping, and yellow is a early science, and the other ones, others more red. Others, this are probably care about this green and yellow. Green is like intensive mapping, so the green observation of intensive mapping. Focus on the student projects, early science in this period. So that's why you see some results from the students in that period of time. Yeah. So now going back to the intensive mapping. Yeah. YTL shelter status, so 15-year-old structure is a shelter. It requires 2 on-site operators to open and close. Yeah. And frequent maintenance required. You should see this. Ripped and in danger of failure. And this is the motor drive closing, opening the shelters. The pipe is old. And here are the shelters options. So we could replace it with different options here, different designs, different vendors and different costs. So this Astro Heaven look like this, and China Steel Structure Corporation look like this, and cost about this is cheaper than that, and also clamshell, it's not shown here, and the fabric replacement, the creative tent, and signature structures, about 130K, and the motor replacement or upgrade. And this is a budget, so about 1 million USD per year, 700K in kilo. Also, upgrade capital spending has been completed. This time, funding primarily for operational size. Increase of 100K winter force transition from 2 to 4 full-time operators. One-time increment needed for shelter repair, and as you see in the last slide, about 100. Is it 1 million? 5 years science campaign. This is the timeline. The YTLA. Science with instrument and with competition will determine need for future experiments. So we may increase bandwidth, better sensitivity, and 60 bigger dish, 60 centimeter dishes, and lower frequency 1 centimeter receivers, broader set of few targets, plus overlap, robotic operations, and second platform. And this is the time preparation with rating spectrometers integrated with test detectors and scored readouts. So engineering run in March with ARO, 12 meters, and planet images obtained. So these are 3 planets. This is Jupiter. These are other planets. And there's the telescope. But it's not just here doing this. So as I said before, this SMA launch program and another telescope as well. SMA, the power heating of CFA, ratified in, 5 hours approved on SMA for intense mapping. We're plotting this area. This is frequency, and this is the line power. So this is a VLA. This is cost to ALMA's over here. This is SMA, so 500 hours. Half of them already observed in early 2019. Targeting Cosmos S-asks DS-IJ transitions. Complementary to YTLA in J in different transitions, different redshift, and different power spectrum wave number structures. Should look for cross correlation with YTLA. They had this team meeting last year. Those photos. And those are the costs. This is kind of summary of that status. So fundamental trace the evolution of molecular gas and information of structure throughout cosmic history, and innovative exploit IA developed digital signal processing engineering task with down converters. Feasible experienced team, well-catalyzed telescope testing technology, and main construction complete. So right now it's doing science. These are 13 antennas, but I think so far 7 antennas installed. Right?
That's right.
The next one is the Greenland telescope. The progress report. Greenland made a flight today, this year. So this is prepared by Satoki and the GRD project team. This is kind of collaboration between ASIAA and SAO. So this is, I think this is impressive. They installed this photogrammetry on the surface. You see these little white dots are those elements of photogrammetry targets. Now, I'm not sure how many of them, a few hundred of them on the telescope to improve the surface accuracy in 2018 summer. So I take the photos. And before the correction improvement, this is, they have 180 micron surface accuracy, which is terrible. Just look at satellite. Because it is a red circles, the pickup points when the dish installed in the receiver cabin. So pickup points, see the pickup points, and drag them up to the receiver cabin. So it may cause this satellite hard pattern of this surface accuracy. So after this photogrammetry surface improvement, going down to 21 micron. Impressive. So random structure doesn't show any clear structures of the surface accuracy. 21 is quite impressive. So with that improvement, we can do full sky maker line pointing. So after the surface, we can do the point line, maker line. The weaker sources are now easily detected, and full sky maker line pointing is now possible. Pointing accuracy for all three receivers, D6, 230, 345, constantly reach more than 3 arc seconds. So you can see full guys scans. The 230 maker line full sky pointing results. You sort of see a range here quite small, few arc seconds. And you can get the first light from the moon. Telescope green line, first light at 345 because receivers you see the moon. As also scan of moon with the 345 receivers. Observed frequency 288, and with the continuum detector. Elevation was only 13 degrees and 225 because opacity was 0.5, so bad. But I still can observe this. So the condition was not great, but still could detect. It's done by last year, September. Greenland telescope is first line, not just the continuum, but also the line toward the very bright evolved star IRC 10-216. This detect the CO line 3 to 2. And also, after some point, you start to detect weaker lines, but not just CO line, strong line, but also these SCN at the tops, and also the SO line. You can see them much weaker than that, as you can detect it. So Greenland telescope joined the first EHC 345 US VLBI campaign last year. With 5 antennas, ALMA, Apex, Iran, Morena, SMA, total of 6 antennas. A strong fringe detected between this ALMA and SMA. Weak fringe, ALMA, Iran, ALMA, and Apex. Unfortunately, no fringe detected so far between the ALMA, GLT, ALMA, and Morena. So not just ALMA, GLT, but also ALMA, Morena. And the CO line approaching brought down the point accuracy to 3 arc seconds. This is done by last year, 2018, in October. These are the people in front of the GLT. Improved the VLBI bandwidth. Yeah. So early, the one that in this EHT campaign is only 32 gigabits per second. So they increased the bandwidth to recording bandwidth to 64 gigabits per second, 4 Mach receivers. So this is EHT backends, and this is Mach 6 recorders. And then increase that to band, and then they got some detection from gas rehearsal with ALMA and UM 30 meters and fringe detected. We detected fringe on early this year. You see the amplitudes very nicely. because the bandwidth is very, the bandwidth they receive is crucial. And then we do a East Asia. It's not just global, also East Asia. LBI test with solar anti-atmospheric research telescope in Japan, and so radio astronomy observers in Korea, and then green antennas 1, 2, 3, and then now the data will be correlated as Shanghai Observatory in China. They do a global meeting because LBI array, 86 gigahertz observations. So it's now constantly joining the 86 gigahertz observations and spring and fall. So I just already 3 times already. The first GRT, 86 gigahertz VRBI data set have been distributed to the PI and currently under the data reduction process. This is the cleanest snow, I guess. So now they have this DIs installed. You can see this DIs have been just installed on the dish. So it's like 2 hours, 1.5 hours, 2 hours, almost 2 hours, 3 second intervals. You can see the eyes melting away from the dish because there's the eyes in it. So you don't need to use the spoon, the broom just to clean up it. And also because there's black so people are interested. VIP visit to the GLT, the Neil Tyson visited the GLT site last year, March. And EACOA. This is Game of Thrones. I haven't played the game before. I'm not sure what it is. But it looks like every time I look at the YouTube, there's a commercial come up. It's always Game of Thrones. Why? So this is EACOA. And then the Prime Minister of Denmark also visited Greenland last year. Hoping to have some collaboration here. So collaboration with Danish researchers. So we are starting to collaborate, GLT teams start to collaborate with Danish researchers. Astronomers have a lot of experience in single-dish science, offline and team science. We can do with terrorist science. Co-environment researchers, they have a lot of knowledge, experience from heavy equipment and the co-environment like the GLT site, like the Greenland Summit tool. However, Danish researchers will save millions of dollars for the summit development. Hopefully they get the help from millions of dollars, operating due to their manpower, experience, equipment, etc. They discuss with them. Preparation for the summit operation, permission from Greenland and to possible pass US and Denmark, and budget in Denmark and prior donations. And the Greenland current GLT will have budget, and hoping to get additional budget from the AS and Mars too. It looks like not how easy that would be because they see the budget decreasing every year. But you never know. As the performance pointing almost reaching the specs of less than 2 oxygen is pretty good. So the accuracy for tests, you need to better. So this should be micron. So it's less than 15 micron. We need to study more about photogrammetry. So holography system. Although they have this traverse plan in the GLT, it's quite ambitious. They need to plan how to assemble the antenna, move it to the summit. And need to design the living and office platform, and electricity, diesel, power plant, and wind generators. I think this is the last slide. So my talk is end here. So.
questions. For the ALMA statistics, I guess everything is done sort of per proposal. Have you done any statistics of request time and the amount of time that's given?
Yeah, that's something. Yeah, you know, have you
Is that similar to as the per proposal success rate?
You have the number? You don't have the number. You know, it's the ASIAA Panel. He's kind of monitoring this statistics. Anthony did. Anthony, are you here? Yeah, can you say something about that? The question is the proposals, success rate in terms of time request instead of number of proposals.
Well, it's only in terms of successful proposals.
Yeah, I know, but how about in terms of request time?
I think we didn't consider the time.
I'm sorry, we should do that next time.
Yeah.
I think we did that sometime before, but the number is probably kind of similar, right? I remember now.
Is this the TAC process or SMA? All the Taiwan proposals still put into one big TAC with SMA?
Yeah.
So how is this idea of moving or try to get 50% of the time on the big project? How would that sort of mesh into just the fact that there's an overall TAC rather than just a Taiwan TAC?
Nami, you want to answer that? Now we can answer that question.
So the current idea is that we going to do that separately. So then currently the SAO side is running the large scale project. Then they organize the separate external TAC for the large scale project, and also the regular TAC for both process. Then we haven't decided yet how to review, but the current plan is doing it separately. Then only the regular track, rest of the half, regular track, will be go to the kind of same procedure.
So just the Taiwan time is the whole TAC. Like determine if they're a large program, it will be determined with the Taiwan time for the PI, you only give 50% of the time to that to the big SMA TAC to divvy up. Is that what you are anticipating?
The current idea is separate the Taiwan's share to 50 and 50.
I think we just started this discussion early this month, right?
Yes.
Early this month. We haven't had any conclusion yet.
Well, probably at least in our institute there is no objection.
No objections.
Yeah. I also asked the university people because the regular time is will decrease. But so far, no objection.
Yeah.
So some university people also agree this idea. But next step is how to review that kind of proposal in a sort of not very large but large scale, our large scale proposal. How to review it in the next step.
You had early on in your slide UCAT, the University Consortium. How do they get funding? How do they work into this?
They have different separate proposals.
So they do have funding through a separate proposal?
Yeah, they submit to the boss.
Okay. And how many people are in that group?
17 so far, faculty members. I think it's increasing. Yeah.
Okay. I had a question about CARTA also. So is CARTA being, over the next, I don't know how long, whatever the schedule is, integrated into ALMA and Casa Viewer being retired?
Yeah.
What's the schedule for that?
Yeah. In 1 year time scale, hopefully. Yeah, as well.
So the ALMA board has agreed to that?
Not yet.
Okay.
Yeah.
But that's your goal in 1 year, CARTA?
Yeah, I think the goal is to replace the Casa Viewer. Yeah. And so far, the function Fortinet is not enough yet. We have to add them in. Yeah, so it should take about a year or so. Something. I think before we had this manpower crisis in how to hire people, and now we have different 4 teams members. We have from the ASIAA, NRO, and South Africa, and now we're adding University of Belgium. So hopefully we can achieve this goal to replace the cost of Europe in 1 year time scale. It's our goal.
I had also a question, but it may be that could be answered later on the YTLE array plot you showed of the points, the data points. I think Jeff is probably the one to answer that. Jeff, will you be showing that again in a talk?
I don't think I'm talking at any point. Which question are you?
Then you can talk now.
Yeah. Which slide are you talking about?
This one?
No, the one before that.
Before that?
Before that, that one, yes. Yeah, when I looked at that slide, I didn't understand what the different points were doing and why there was so much different signal to noise on the different points.
Yeah, so first let me say this is a very preliminary result. The signal to noise is actually the same on, or roughly the noise level is roughly the same on each of these, but the fact that we're seeing much higher signal in a couple of the K modes is indication of some kind of crosstalk in the system, most likely. So this plot is a result of getting the 2 pipelines that we have to work together. So we have a calibration pipeline that's specific to the YTLA, and we have an intensity mapping pipeline that was developed for the SCA and other projects. And so getting them to talk to each other was the main achievement here. But there's clearly significant data editing and flagging that are required to turn this into an actual result.
Okay, thank you.
Explore, this 4 hours of data, and you're still quite a way off from the most optimistic theoretical prediction. How many hours of data do you expect to get in the end? Total?
So we require a few thousand hours spread over a number of different fields in order to get the design sensitivity that we want. And that is the design sensitivity is to be near that green dashed line, model A, on there. So we are, as you can clearly see, we are, orders of magnitude away from that. I wouldn't, I wouldn't read too much into the particular values that are here. I think they're right, but there's a lot of optimization to be done, and this is not what the best 4 hours of data from the telescope will give you, or what we think the typical 4 hours of data from the telescope will produce. But it does require, basically continuous use of the telescope over several years, and that's the motivation for this 5-year plan to build up the sensitivity over time.
When do you think you're ready to go into the production mode?
That's a goal for this year, is to make that transition. Over the past year, we've done a lot on commissioning and on operations, a lot of very mundane things about just operator procedures and telescope procedures. A lot of that's been ironed out. We're still resolving some issues around the sensitivity, but in the next year, I think we'll make the transition to full-time science.
Thanks. Okay, I have questions concerning the ALMA bridge and second mode. The scientists working on this, I guess, are postdocs, and I also guess they have a certain split between service time and their own science time. What is that split? Approximately 50-50? Or?
The ARC members? So far, 50-50, but the loading actually less than 50.
Yeah.
Because they have some automatic pipeline already. So about 30% and then 7% right now.
Right. What is the usage of other Taiwanese universities on the ALMA regional center node? What percentage of the time do you serve the other universities? The ALMA regional center node is Taiwanese, it's not only ASIAA. So you must also serve the other Taiwanese universities.
Yeah.
What percentage of the total effort goes into the other universities?
I think a lot of the users from Taiwan, from universities. Yeah, a lot of them. How many percent of them? Like, I think mostly Tsinghua and NTHU, NCU and SIDA. The UCAT, mainly UCAT members have 70 faculties members and have students. And that last cycle, there are a lot closer from the students in NTHU accepted.
Concerning the Greening telescope, I'm astonished that you get 20 micron RMS from photogrammetry. But anyway, that's really interesting. I thought you would need photogrammetry to do that. You mentioned Danish groups, this experience, this lot of experience in single dish astronomy. What institutions are they coming from? I'm not quite familiar with any groups in Denmark. What institutions in Denmark are involved in single dish?
It's mainly Dawn and Starplan, so that the University of Copenhagen and Danish Technical University is the main two universities.
What telescopes are they using now?
Basically, they have access to ALMA and I believe EASO telescopes.
And one of users like Jorgensen.
Well, I know they're using ALMA a lot, but I'm not very familiar with them using single dish telescopes.
Well, probably, I'm not sure. Apex, probably some Apex, but yeah, they're really interested in the terahertz if we go up to the summit, and that's the main interest from the Danish group.
Yeah, regarding the Greenland telescope, to produce the designs for the buildings and traverse plan and the logistics requires a lot of non-astronomical expertise.
Yeah.
So who's doing all that stuff?
Mainly we're working with Chongke, National Chongsan Institute of Science and Technology in Taiwan, Chongke. We're working for a long time since SMAP construction and those things, which they also build because they build the airplane, so that they have the cold chamber and cold environment technology, and that's how we're discussing it, but not much yet.
So it'll be still a learning process.
Sorry?
There'll be a lot of learning process associated with that.
Yes, but we start working on that. Yes.
So for our proposal, I believe you still have two paths. One going through Japan, the other one goes through the United States. So what's the balance between that? And if one side have the more of a subscription, of course it's better to have more balance. So what's the balance between them? And the second question is the SMA. Apparently, of course, you need more users, and you try to organize some workshop or whatever things. That's cool. That's good. But where you would actually find potential users? Do you have any active access to try to find expand the users?
Let me answer the ALMA point, then I can answer the SMA point. So you're asking the balance between the East A and North A, North American, the proposal submission requirement, I guess. So far, I mean, a lot of people here just submit to the EA because it's better, easy to get time. You get time, it's a reality. So that's the issue.
Well, you should check the actual success rate.
I know, but yeah, the oversubscription is just NA is still higher than the EA, slightly.
No,
And
it's lower, it's been lower for 2 years.
it's quite similar, but the proposal quality is higher in the NA. So if you have the same proposal, same ranking, you might not be able to get time from NA, but easily get time from EA. And that's why still a lot of people here submit to EA. Yeah. And for example, last cycle, there's no accepted proposal from NA, and most proposals are accepted from EA. Yeah. Same proposal, I guess I submitted to NA.
Well, probably stronger proposal were not submitted to the United States. Probably stronger proposal were not submitted to the United States.
I tried it. I submitted my strong proposal to it. I got a high ranking. If I submit to EA, I'll get time. I just compare that. But I didn't get time because I submitted to NA.
Yeah, actually, we encourage people who have successful past history
Yeah, that's
to
why.
go to the NA.
Someone had to.
But it turns out it's like punishment.
No, someone had to show some sacrifice. And that's why I submitted. Sorry. Yeah, I sacrifice.
So we have statistics, some statistic for EA and NA for ALMA.
The NA is about 4 or something. The NA, EA about 4. Yeah, but which one is higher? Which one is higher?
No, I mean, for the Taiwanese proposal.
The sample size is too small.
You think it's too small, but you can add up all the years.
It's still too small and too noisy.
Well, you're just taking whatever statistic you have in the table, then divided by 2. So it will not be too noisy. It's 1.4. Unless there's so few NA proposals. If that's the case, that is an important data point.
Sorry, what was your question? Accepted proposal? No.
No, because you're discussing, the difference between people sending EA and NA.
No.
What about giving some quantitative number?
Okay.
Over the years, how many proposals submitted to EA, how many to NA, and what is the success rate of
Last year,
these two categories? And what, where I was saying is that there's so few proposals submitted to NA that there isn't good enough statistics.
Yeah, we do have the numbers. If you want, we can provide it to you.
yeah, we
But
do have numbers.
personally, when I look at the number, I don't believe I learned anything from that. Because first, the number of proposals submitted to NA is too few. Second, there is a selection process in that. We push certain people to go to NA.
I would say simply providing the number of proposals which you submitted to EA and NA is an important piece of information.
Yes, we have that.
Seems like last year, the 10 proposals, or 5. Last year, how many proposals remember to NA?
Okay, around 10.
Around 10, but no accepted. Mine is a failed project because you have submitted to EA, frankly, but
So it's 10 out of 70 something, right? Remember?
yeah, 10 out of 70. And this is even worse. I won't tell. Should I tell?
Less than 5.
Huh?
Less than 5.
Less than 5. I told them it's higher than last year. I mean, people kind of sense that. Not easy.
So can I add to this? So there is,
Yeah, sure.
within ALMA, there is the belief that there is actually a regional bias, so that just like there is a gender bias, they think that people from East Asia are somehow disqualified in the proposal reviewing process. So in order to mitigate that, this year they have randomized the order of the co-authors on the proposal and the PI as well. So you can no longer tell who is the PI. So you can no longer tell as the tag to what region this has been submitted, I think. So
Yeah.
So we could have taken advantage of that and submitted a proposal to NA.
Randomize the authors list of the authors of the COI and PI.
You know, to bluntly put it, you know, if there's another Wang or Lee or whatever PIing a proposal, your average North American tech member thinks like, I don't know this person, or you know, and that seems to be a bias that's there, and the same with female PIs. So they're trying to mitigate this by randomizing the order of the investigators on the proposal. And we could have taken advantage of that and submit more proposals to NA because the outcome will be different.
Yeah.
So I served for 3 years on the ALMA Tactful Group, and I have to say that never at all in the discussions did the NA or wherever it was coming from come into the discussion of the proposal. So while there may be a statistical bias, it's an unconscious bias because it's never discussed where it comes from.
Well,
at least the panel I was in 3 years in a row.
It's well known that these things are unconscious, right? But the hate just
bias for sure.
yeah.
That's what I mean.
Yeah.
So but I just want to assure people it's not discussed and it's not a conscious effort. If it's happening, it's an unconscious.
Yeah, that's what I meant.
I had a different question. One of the things that is happening here but isn't well outlined is the involvement of students, thesis projects, successful thesis, the next generation. And I don't see anywhere in the statistics that we've been given those sorts of numbers and all across all the groups. And so it's not picking on the radio group, but all across all the groups. How many students are doing master's theses? How many students are doing PhDs? How many PhDs do you graduate per year? This was something that came up in our discussion with your administration this morning, that this is one of their measures, is the talent, the encouraging of talent, the production of talent. And I think you guys need to, produce those statistics in consistent fashion across all your groups.
Thank you for the suggestion. This would be a good idea to add.
Hello. Hi, my name is Min Kai. Thank you. We're about half an hour behind the group schedule, so I will try to make up some time. So my name is Min Kai. I'm one of the, I guess I can still say junior faculty in the theory group, and I'll be talking on behalf of the group and also speaking for Hiroki Yoshida-san, who is traveling, and the slides were prepared by him. So, a quick outline, I will talk a little bit about the current status of the group, the theory group. We'll talk about what we have plans for the immediate future, issues to do with high-performance computing and how the group is managed internally, and thinking a little bit beyond 5 years, so the sort of near future. And I'll try to focus on updates since the last panel meeting, instead of going through the entire group again. So, since the last meeting, we've had plenty of publications, I would say. So the theory group is roughly divided, well, it's everything theory, right? But it's roughly divided into 3 so broad science categories. Number 1 is star and planet formation, to its galaxies and cosmology, and then high-energy astrophysics. And the past year, we've had publications in all 3 major themes. So I did some work on dust dynamics and protoplanetary disks. Mika looked at synthesized images of star formation. And also, Xingyuan had a paper out recently looking at the kinematic implications for protoplanetary disks when you have an embedded planet. So I'm in the first category. So in the galaxy side, we published in numerical simulation of galaxies with dust, evolution of grain sizes, distribution of dark matter, and jet simulation. So we cover a range of scales, from small scales, planets and stars, to large scales like the cosmology. Right? So those are the sort of the latest publications in these areas. So as you already heard several times, we've had several awards received in the group. Taipei has got an Academia Sinica Career Development Award and also an external award. Shanghai also received a Most Publication Award. Something new that has happened last year was Ken, sitting there, organized a Taiwanese theoretical astrophysics workshop right in this room, where he gathered pretty much all the theoretical astrophysicists in Taiwan in this room. It's a 2-day workshop discussing possible collaborations, and I would say that was a very successful workshop because it actually led to actual collaboration. So there's a program led by Pan Guoquan at NTHU, supported by the National Center of Theoretical Sciences, looking at multi-messenger studies of supernovae. So this is a joint collaboration within Taiwan. We also started looking into using national resources in terms of computing. So you can use most grants to purchase computing time on the national cluster. So I've been doing that, and that's working out pretty well, I think. So what's happening in the immediate future? So I would like to think the theorists here are optimistic and ambitious at the same time, in that we envision ourselves as becoming one of the science pillars of this institute, interacting with the observers on a sort of equal footing. So we're hoping to have a two-way interaction in that we try to provide models, theoretical models to observers, as well as make predictions for the observers to check out. At the same time, leave some time for what I call theory. But there is, of course, a challenge to this vision. That is computational resources. As you know, computers are sort of the theorists' telescope, right? So, although I do want to emphasize that not every simulation will require the biggest computers, right? You can do impactful science with intermediate-sized machines, right? But when the number of people grow, like we have in the past few years, while the hardware, the resource have not, that presents a difficulty. So there is a mismatch between what we currently have at the Institute, which is a local intermediate-sized cluster, and the required number of core hours, the amount of resources we need to sort of realize that goal I mentioned. So we have actually put together a proposal to the Institute to purchase a sort of new sort of high-performance computing cluster. We actually accounted for the required computation requirements for the current members for the next 5 years, as well as a projection for the increased requirement to account for new members, right? For example, new postdocs and new faculty. So we came up with a number of about 4,000 to 6,000 cores. For comparison, the machine we have right now is about 3,000 cores divided into sort of smaller sub-machines. So we are aiming to purchase a 4,000 to 6,000 core homogeneous cluster. The cost will be about $2 to $3 million lasting over 5 years, and operation cost of about $1 million over that period of time. And we're currently waiting for the management committee's reply or response from this proposal. So to go along with this new HPC system, we also formed an HPC committee. Now, this is not a sort of official committee of the Institute, but this is something inside the theory group. So it's a very small committee, only 4 members on one of them. And the way we operate is that we try to identify problems with HPC and try to solve them, but we try to account for the opinions and concerns for each member. But at the end of the day, the decision making comes down to this small group, so that we can actually make decisions and get things done. So Hiroshita-san has been organizing sort of semi-regular group meetings, either for all all members or for faculty level, this is the opportunity for everybody to sort of check base with each other so we can keep up to date and discuss any issues to do with how the group is managed. We are also holding a theory group workshop in August. So this is an opportunity for both the internal members to learn about the other members' recent research results. It's also, of course, open to the entire institute, right? That's one of the purposes is for the other institute members to know what the theory group is up to. So I think that's sort of a new change since when I came in, when I started 3 years ago here. So regular meetings within the group, and also what we're about to do is to have a sort of a theory group expo in the summer. So thinking a little bit beyond 5 years, we think the longevity of the theory group will depend on collaborations, right? So I think a good collaboration, good network is sort of vital to the longevity of our group. But it takes time, and so we are starting from the smallest scales, right? So we're starting from within Taiwan itself. That's why the theoretical astrophysics workshop was organized to try to gather everyone in Taiwan to start with, and once we have that unity within Taiwan, then we can think further beyond that. In terms of hardware, as I said, that's always been a challenge. But we are thinking of possible solutions. So we have, as I said, we've sent a proposal within the institute. We have also been thinking about proposals with other institutes, either other universities or other institutes within Academia Sinica. So there are some thoughts on that front. We also are thinking and actually have been using the national cluster as well. So that's also something new since last year. I've been using Moscrap to access those machines there. So in summary, I have an optimistic outlook for the theory group because we are publishing steadily. We have sort of reorganized ourselves. We've identified major research themes that we want to focus on. We are publishing in those areas. We have put together an actual proposal to purchase a new computing cluster, submitted that to the institute. We are receiving rewards and grants, and we are sort of starting to play a role in uniting the theoretical astrophysics community within Taiwan. Yeah, I am hopeful, to be honest. And that is all I have to report today, and I'd be happy to take any quick questions in the interest of time.
For your future presentations, I would appreciate a bit more details on what the technical expertise of this new theory group, which is a great idea, by the way. But it would be really nice to know, first of all, who the people are, what their expertise is. Is it analytical? Is it semi-analytical? Is it code development? Or you just simply code users? If code development, exactly what code? What techniques? Are they internationally competitive?
Sure.
And so on and so forth.
Sure. Thank you for the.
Let me finish. The other point is that I think it's a very important discussion to have. Obviously, a big part of theory is computational, but how do you go about realizing your goals? One approach which you are presenting here is that you want to basically build and maintain your own hardware. An alternative approach would be to use grant or institute money and gain access to hardware that's built and maintained by others. Okay, this is a very serious question. There are pros and cons to that. It's not entirely obvious that it's cost-effective and sustainable to always maintain your own hardware. Just like it's not obvious to me, to put it back to the observers, that if you need telescope time, you need to build your own telescope. And maybe there should be a balance between the two, but that's a very important discussion to have. Because once you go down this track of building hardware, as you know, hardware only gets more and more, and they could have to be replaced every few years, and then you need to maintain it, and so on and so forth. It becomes a monster of its own. That's why there's supercomputing centers that do this professionally. So this kind of cost-benefit analysis needs to be done very carefully.
Yes, thank you.
Yeah. So I just have to follow up. So when you say for certain computation requirements and over a certain time, you would have 4,000 cores, but then after a certain period of time, you have to renew that, right? Upgrade them or replace them, right? So it's a continuous cost on a longer time scale. It's not just 5 years, right?
Yes, that's the ideal model. The ideal model would be every 5 years well, 5, 6 years is an injection of funds to replace either buy more time on some other cluster or maintain or renew our own current clusters.
Okay, and I guess another question, also following up from Lewis, is about technical expertise. And so, of course, as you mentioned, you like to explain observations, bridge theory and observations. And so one aspect of this, you have radiative transfer, hydrodynamics and magnetohydrodynamics. But what about chemistry? What is the group's thinking about that?
Yeah, so we do have a sort of sub-project within, within theory group called CHARMS. So Mika is involved in that, the paper he actually put out was part of that effort.
That was in chemistry, though.
Right, but it's radiation. It does include radiation, right? Radiation transfer. Right. So yeah, I think that aspect we will continue to invest in.
Is that something area you're going to look into in the future, or
Yeah, at the moment, that's a lot of that is part of the solar plan formation effort. So I guess you can say the CHARMS, the astrochemistry side, is sort of part of star plan formation. So it sort of includes.
Yeah, actually, that's you obviously at the moment you have two distinct areas. One is that is concentrational dust, which naturally needs into indeed, as mentioned, chemistry and to molecules that get the dynamics. But the other large area is large-scale structure formation, and there, of course, there is a worldwide there are leading efforts to make photoshriggles, illustrious, or whatever is the newest version. And how does ASIAA see its niche here? Do you do something that they don't do, or complementary, or what would make your effort distinct from already other existing large-scale efforts in structure formation simulations?
Okay, so you're asking how are we different from other people, right? So I think astrochemistry is certainly one aspect of it, because we do have a lot of heavy observer presence in the institute. So I think one advantage we have is a close connection with the observers. So that's one area that I think we're going to try and focus on as you mentioned, the bridge between theory and also. So I think that connection there, especially in the context of protoplanetary, because I'm in this field, so I know one of the emerging sort of trends is to bridge. So I think this is a niche where the group can take advantage of.
So I had one last question on the cost. In the material sent out ahead of time, it was talked about as a single machine bought from Cray, and here you present it as $3 million over 5 years, but really you need it as one shot, don't you? Or you actually think you'd buy a third of the machine or a fifth of the machine each year?
So can you just?
Well, in your presentation, it was characterized as a certain amount of money over 5 years.
Yeah.
But is that really how you want it, or in order to accomplish?
Oh yeah, sorry. Thank you for pointing that out. Yeah, I understand now. Yeah, so it would be a $3 million injection
Right, so it's not really over a period of 5 years, but it's for, your view is it would last for 5 years, quote
Yeah,
unquote.
yeah, so the
Okay.
operation would be for 5-year periods. I think we need to move on, so welcome the next speaker.
I should be rather quick. So just give you a very brief report about the status of the EACOA and the EAO. So the EACOA part is incepted in 2005, and as you know, it consists of an AOJ and AOC CASI and ASIAA. And the aim is to construct powerful and cutting-edge astronomy in East Asia. So the funding level from ASIAA is on the level of a couple $100K, and mainly for the EACOA fellowship program. So the activities of the EACOA basically is just holding collaborational meetings, regional collaborational meetings, collaborative meetings, and also host the EACOA postdoc fellowship. So in the coming year, we expect the East Asian Young Astronomer meeting to be held in China. And last year, we projected to have the East Asian meeting for astronomers to be held in Japan this year, but it's probably going to be postponed to 2020 next year. For EACOA fellowship, it started from 2012, and we have been hosting so far about 13 postdoc fellowships, and these are the current 5 postdocs. And as you see, the names with the underline are those who have been stationed in Taiwan. And the red host institutes are those who have moved, these postdocs move on to with tenure track positions. So you see, we have been pretty successful in acquiring EACOA postdoc coming to Taiwan among all the postdocs, and many of them have been moved on to a successful career path. And in this year, we're going to have 1 person leaving for Shanghai Astronomical Observatory, and we'll have 3 new postdocs coming in. So for EACOA, basically the benefit to the IA is, as you see, is an entry point for regional collaboration, and we have been very successful in having EACOA postdoc to work with us. And a couple of things to be looked out in the coming year is the future format of the EMA meeting is projected to be more topical based rather than just a regional gathering, but this is going to be decided. And there has been concerns raised regarding the effectiveness of the EACOA fellowship program, and this is currently being watched over. So let me move to East Asian Observatory. It is established and incorporated in 2014, and the mission statement is to pursue joint astronomy projects with the East Asian region. So the IA contribution is at the level of 500K or so, from considering the overall regional contribution by EACOA, or about 10 or 30% for the year total budget. And this budget is mainly used for the management and the operation of the JCMT, which is the first facility and currently the facility being operated by EAO. So what happened in the past year? The first thing is the exciting news about the first imaging of the supermassive black hole, which JCMT is involved. So if you always see the science news, so I just want to highlight this picture with this Hawaii name for the black hole. Is called Hawaii, and this is to let you know the popularity it gets from this scientific result. And the name of this, the Hawaii name is given by Dr. Larry Kimura, who is a professor in University of Hawaii in Hilo, and he's an expert in Hawaiian language and culture. So he mentioned that the Hawaii is basically a dark source of unending creation, and this is a concept emphasized in the creation chain of Hawaiian culture. So because the importance of the JCMD as well as SMA involved in the AHD experiment, so the Hawaiian government is made the, it's hard to see, April 10th of 2009, the Hawaii Day. So that's to show you how the event or the science discovery engaged with the popular general public, and also to get the attention from the politicians. Okay, the publication from EAO is holding steady and slightly increase on the trend. And particularly important is the East Asian publications is increasing within the EAO, the JCMT. And so the publication record in 2008 continues with a steady growing number. And in total, 7 papers out of the 34 East Asian papers are from Taiwan. So EAO is continuing to make regular calls, proposal calls with a reasonably healthy oversubscription rate of 3 or so. And EAO is developing a new 3 frequency receiver, and this is being commissioned now on JCMT. And EAO bylaws was amended by the EAO board directors last month. So a few things to be looked out in the coming future. Okay, let me just, we can just skip this one, and just to say a few things to be looked out in the future. One difficulty or one problem right now with the EAO is the funding situation, because NAOJ is pulling out their around 700K contribution, annual contribution. So this creates a substantial budget deficit and cash flow problem. So currently the EAO is trying to mitigate this problem by one-time allocation from partners to clear the deficit, and also for the long-run budget reduction from retiring senior staff into remote operation will be pursued. In the meantime, EAO is exploring new regional partnerships, including Vietnam, Thailand, Malaysia, Indonesia. Okay, so in the long run, these new partners may bring new funding for the continuous operation of the EAO. So in the meantime, EAO also continues to have collaboration with regional facilities, like the SMA is found through Taiwan is sharing access with other regional EA regions. And also EAO supports the regional scientist access to ECURT. Just last week, there is a meeting on the Summit Future in the East Asia was held, and they discussed about the new A50 micron camera development, and also the East Asian VOBI projects, and also some future instrument development. So that's basically it. I'll just stop here. Thank you very much.
What is the complete budget, the total budget of the JCMT per year?
Currently it's about 4.5 million per year.
How much?
4.5 million.
4.5. So if Japan decreased to 250,
yeah, they were.
That's a very big reduction.
Yeah, they were contributing at 950K previously, and they reduced to 250K. Yes. So.
Okay. Well, what is you said at the workshop last week, the design of a new 850 micron camera was discussed. You know, Scuba 2 with 5,000 pixels is really still the state of the art. how would such a new camera look? Why would such a new camera be planned even?
I believe they're looking for even quicker mapping speed, probably 10-fold mapping speed or something like that, with double the pixel size or so. Maybe Paul can comment on that.
So the new camera will be 10 times faster in the total power mode, and for polarization work, it will be 20 times faster. That's the goal. So it fills out the focal plane more, and the detectors are better, and each of the pixels will be due polarization.
What technology would it be based on?
MKITs.
Okay, well, good luck there.
So there are 2 points in the slide that one of Professor elaborate a bit more on. One is you mentioned about the issue with the EAO fellows.
Yes.
So you can explain what they are. The other one is about changes in the in the bylaw, or whether the EAO bylaws.
Right. Yeah, so the fellows, you're asking how the fellows are selected, or
no,
or
you mentioned their issues.
The issues, right? The issues mainly we consider the EAO fellowships are the EAO fellowship a prestigious position, and we sort of treat them as very independent researchers. So sometimes they're too independent. That means they work by themselves. But the goal of the program is to encourage collaboration between the fellows and their host countries, and also they are because they are asked to station at least at 2 institutes, so they should play a role to bridge the collaboration between the institutes, and those goals have not been well met yet. So that's something we need to work on better. Does that answer your question? Okay. And about the bylaws, so the bylaws were made initially at 2014, 2015, was because at the time there needs to be a quick establishment of the EAO. So the bylaws probably in general is not very tightly structured. So this last meeting just try to amend it to be more well defined in terms of some of the roles of the institute and the structure of between like the directors and the institutes and the observatories.
Okay, I think this is a good point to stop. Now it's lunchtime.